So we're dealing with the law of cosines. The LOC stands for the law of cosines, and these are the two cases that we're going to have. If we're given side angle side or side side side, then we know we have to use the law of cosines. So what I mean by that is, like, for example, this one here. So we're given an angle and we're given two sides. Notice how the angle here is not opposite of A, it's gamma, so it has to be opposite of C, and we're given A and B, we're not given C. So that means that this angle has to be between those two sides. So if we're given an angle there, I know that if this side is C, this is here is gamma, then this side here is going to be given to us. This is going to be side B, and this has to be side A. So anytime that you're given one that's not next to it, it has to be the angle next to in the middle of it. So A and B, this is not the angle opposite, so therefore it has to be side angle side. So that's how you know that's that one. Or if you're given all three of these are sides and no angles, then you're going to have to do the law of cosines. And you're probably wondering, what is the law of cosines? You've probably seen it a little bit before. We talked about it briefly on the law of when we're filling in the flow chart for the law of sines. There is, it's a little bit long, but once you realize what it is, it's not that crazy. So the law of cosines is going to be, if we're given, say for example, this one here, we're given gamma, so we're given the angle gamma. So if we have gamma, then this side before here has to be C. So, and then of course, it's going to be the law of cosine, so we're going to have the cosine and the angle. And again, this is C, so that means that the two sides that are given, the A and the B, are going to be somewhere in here. And everything is going to be squared. So we're going to have this to be squared, and so therefore we're going to have this different kinds of combinations. So we're going to have A squared plus B squared. So we're going to have that, and then we're going to have minus 2A times B. Now, here's the thing that you need to remember, that these triangles that we're given are oblique. That means that they're not right triangles. So if it were a right triangle, that means that the angle that's given to you would be 90 degrees. So if this was actually gamma is equal to 90 degrees, this angle would be the cosine of 90 degrees. Well, if I do my left-hand rule and I do the cosine of 90 degrees, I know that the cosine of 90 degrees is 0. So I am going to have 2 times A times B times cosine of 90, which is 0. So this is going to be 0. So if I have this, C squared is equal to A squared plus B squared, this here is actually, if you guys remember it, the Pythagorean theorem. Not because it's C and A and B, it's because this one here is going to be the biggest side. 90 degrees is the biggest side, so it's actually leg squared. I'm sorry, nope, not leg squared. It is going to be hypotenuse squared equals to leg squared plus leg squared. So if it was a right triangle and this angle that's given to us is 90, it actually is the Pythagorean theorem, which is what we do to solve a right triangle. If we're given two sides, we could find the third side using the Pythagorean theorem. Now, the angles, because we're talking about the law of cosines, it is not going to be 90 degrees, but the Pythagorean theorem is embedded in the law of cosines. So that's not what we're talking about here. So we're going to change this a little bit because we're not going to be given the 90 degrees there, but just so that you know, the Pythagorean theorem is hidden in there. What do I do? Let's solve this problem. So solving the problem means I have to find the side that's not given and the two angles that are not given, because we're given two sides and one angle, and we need to still find the other sides. So what I am going to do here is, since we're given that angle, I need to find C first. That's what I need to do there. So I'm going to say C squared is equal to A squared, which is 14 squared, plus B, which is 10 squared, minus 2, 14 squared, we're multiplying, and then 10 squared, and then the cosine of 82 degrees. So then we could just put that into our calculator, and you need to remember that I have to get C, not C squared. So I'm going to take the square root of both sides. So this is going to be the square root of all this stuff. So we are going to take the square root of this side and then take the square root of that side. Anytime I take the square root of both sides, I am going to do a plus or minus there. There is always a plus or minus when you take the square root of both sides. Don't forget that. Now, because we're talking about a length of a triangle, the side of a triangle, we do not need the negative part, but because we don't do it all the time, we forget about it, especially when it's definitely necessary. Okay, so then I take the square root of both sides on there and I solve it, and I end up with the square root of 75.0315 dot dot dot. I put this into my calculator and I store it because I need to find the exact answer. I can't write all that big number, but if I store it, it's going to be there. And then my answer at the end when I store it is going to be C is going to be 0.33 dot 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 meters. So going to our calculator, let me see where my calculator is at. It's right here. So going to my calculator, that's what I've entered already in there to save some time. I got the 16.03322. I store that in C because that's the side that I found on there. Now remember, it's control and then right above the bars button, right above the 9. So control that has store, and then I hit C and then it stores it in C. So we'll be back to that in just a second. Let's go back to what we were doing. And in this case here, we talked about that this one here is in centimeters. So it's 16.03 centimeters. That's the side opposite. So I am going to put that in here. I am going to put that in here as 16.03 centimeters. And that's the length of C. Okay, so we are not done. We still have to find the measure of angle A and the measure of angle B. And the nice thing about the law of cosines is that once I'm done, I could go back to the law of sines. So now I have enough information where we're going to be able to do the law of sines. The reason why we can't do the law of sines on here is because we do not have enough information to be able to solve it. And so what I say about that is if I were going to, before doing the law cosine, I could go ahead here and try to fill it in. So I know that it would be the sine of an angle over the opposite. So if I say the sine of an angle, which is 82 degrees, and the side, I don't know the side opposite, has to equal to the sine of an angle, and I could say, alpha right here. If I do alpha, then I am going to then do, here has to be 14. If I had not calculated this C, I would not know this C right here, and I don't know this alpha right here. So I would have two unknowns, and I cannot use the law of sines to be able to solve this triangle. So that's why I have to use the law of cosines. But once I found out what C is, now I know what C is, I could actually use this and find what alpha is because now I only have two unknowns. I have no choice. I have to use what I found. And since I stored it, I could actually put this into my calculator really nicely and be able to solve it. So what we do is we want to get the alpha by itself. So we're going to do that cross multiplication. So the cross multiplication is going to give us on here 14 sine of 82 degrees. Now if I multiply this, I'm going to move this to this side and I don't want to. So I am not going to cross multiply that side there. I'm just going to do those on there and I am going to keep this over C. Draw. I'm going to keep that over C, and that's going to equal to the sine of alpha. It's the same thing as multiplying both sides by 14, which works out the same way. And then I have to get the inverse by itself. So I am going to then have the sine inverse of 14 sine of 82 degrees all over C is going to be my alpha. Okay, so now what happens? I put that into my calculator. So let's go back to the calculator. And that's what we did over here. Well, I did the cosine again. I did not do that on there. And I could put that in there in the calculator the same way that it shows there. And I didn't put that in there. I did it using the law of cosines again, which is fine. But doing this one here, I would end up getting the same exact answer as alpha, going to give me 59.8535 0.50. When I put that into the calculator, that's what it actually gives me. And so the alpha is going to be 59 point and then 85 degrees. So that's the angle there. So this one here, just so you could see again, this is actually using the law of cosines again. And I'm going to do that in just a second so you could see how we're going to solve that on there. And then, so now I know what this angle here is. I have everything filled out. So I know this angle and that angle. I know that they have to add, all three of them have to be added up to 180 degrees. So when I add those two and subtract it from 180, I end up that this is going to be 38.15 degrees. So all you're doing is adding those up and subtracting them from 180. Okay, so now what if I hadn't done the law of sines again? I could continue doing the law of cosines. So the law of cosine says that I am going to do the 14 squared equals to 10 squared minus c squared, because I already know what c is. I'm sorry, plus, because it's the Pythagorean theorem. This one here is a square. The a squared is equal to b squared plus c squared. They just switch on the order. And then it's going to be 2 times 10 times c cosine of alpha. So I could do the cosine, the law of cosines twice and still get the same answer, or I could do the law of cosines and then do the law of sines and still get the same answer. So here, because I am going to try to find out alpha, I need to have this one up here. This here is going to be A, and this is my alpha. So this is going to be A, and then this is my B, and that's my C, and this is my B, and that's my C. So just interchanging this, the main thing you need to remember is that the one outside has to be opposite of the angle that's given. So how do I solve this? Well, C is already one that I stored into the calculator. So what you're going to do is you're going to say that this is 14 squared. This is addition, so I'm going to subtract it over here, and that gets 10 squared. And then I subtract this, and I get negative c squared on this side. And then this here is being multiplied to the cosine. The negative 2, 10c is being multiplied to the cosine. So in order for me to get it to the other side of the equal sign, because I moved this one and I moved that one, so now I need to move this, is that I could only do it by dividing. So this one here is going to be dividing. And this here, notice I cannot move the whole thing. Some students try to do that and move the whole thing, but you can't because these two are attached through multiplication. And then I have to get rid of the cosine. So then we do the cosine inverse, and that gives me alpha by itself. So I subtract the 10, I subtract the c, I divide. This whole is one term right here. I divide that, and then I have to get rid of the cosine. So I take the cosine inverse of this, and that's the alpha. And this is what you see here. That's the cosine inverse. The c is stored, and this is what you get. And notice how it's the same thing, 59.8535, which is what we got when we solved it this way over here, the 59.8535 using the law of sines. So you could do the law of cosines twice or do that and you're still going to get the same answer. So we entered the side of 14 and the side of 10. And so here we wanted to find the opposite side. So this is an angle of 82. So this is side, angle, side for what we had over there. And so if we look at this, I could enter the angle that the side that we set and see if it's going to happen. So if it is going to happen and appear, this is going to turn green. So if I do that, I am going to enter the 16.03, and we should have, let's see, I have that 14, 10, 82 degrees, hit enter, and there it is. That's the one that actually appeared right here. It's the green third side, so then I know that I am right. So that's what it's saying. Here's the third side. Notice this is 82 degrees, that's 14, and that's 10, and then we have that. Very good. Okay, and over here, we have this one here is side, side, side. And so when I look at that, We already have the 5m, the 7, and the 8, so now we just have to find the angles. So how do I find the angles on there? And so what we're looking at now is that we're given the both sides. So this one here, let me look at that. Let's go back to what we have here. All right, so now on this one here, we are not given, let's change this. So now we're going to be given this angle, which is the side, which is going to be 5. Um, and then the other side is going to be 7. Oops, I said 17. 7. And then the third side, because this is side, side, side now, this one here is going to be 8. So now we have a triangle that looks like this. Okay, so if we have 3 sides, we're going to have to find out which angle we're going to have to find first. In order for us to know which one it is, it depends on how you're going to solve the problem. So we have to use the law of cosines first. But if we are continuing to solve the triangle and we want to go to the law of sines, we have to know whether the biggest angle is going to be obtuse or acute so that we know how to go forward on that. But if you use the law of cosines and you continue using the law of cosines, it really doesn't matter which angle you find first. So just get into the habit that you always find the biggest angle first. So if I'm looking at this, the biggest side is the third side. So I want to find beta first. So as I am going through this, I am going to need to do the law of cosines to find this beta. And then we're going to come back and check and see if it's correct. So this is the angle that's going to be the biggest on there. So when I'm looking at this, I am going to solve I'm going to solve, so I'm going to have 8 squared because that's the one, and I am going to do the cosine of gamma, which is going to be the biggest side there. And then the other 2 sides are going to be here because I have to do the Pythagorean theorem. So it's a squared, and then it's going to be 5 squared plus 7 squared, Pythagorean theorem. And then we're going to attach the rest because it's not a right triangle. So it's 2 times the 5 times the 7 times the cosine of gamma. Okay, and so then we're going to solve it the same way we had before, 2 squared minus 5 squared minus 7 squared, and this is all going to be divided by the negative 2 times 5 times 7, and so that's this part right there, and then we want to get rid of the cosine, so we're going to do the cosine inverse of this, and that is going to give us what gamma is. And so once you put that into your calculator, what you are going to get is that gamma is going to be approximately 81.7868 dot dot dot. In this case here, it's going to be degrees. So that's what we have, not meters, it's degrees because it's an angle. So we're going to have that that's what gamma is going to be. So when I put that in there, I'm going to put this 81.79 degrees. Okay, and so then I have to, now I could do the law of sines again, or I could do the law of cosines. So how am I going to do that? Let's do the law of sines on there. So we're going to do the sine of beta over 7. I'm finding beta next on there. And so I know that that's going to be 7. And I've already stored gamma into my calculator. So I do sine of gamma over 8 meters. And so this one is known. The only one that's not unknown is this one right here. So I want to get the beta by itself. So that means I am going to move this one over. And so I am going to get 7 sine, not sine, sine of gamma all over 8 meters. And I need to also get, so that one moved over here. So that's the same thing. And then I need to get the sine by itself. So I am going to do the beta is equal to, and I do the sine inverse of this. So what we did is we moved a 7 up here because it's the cross multiplication. I still, then I will have sine of beta equals to this quantity, and I need to get the sine by itself, so it's beta on there. I put that into my calculator, and then I get beta is approximately 60 degrees. It actually goes into approximately 60 degrees. So that means that this here is approximately 60 degrees. These two, when I add them up and subtract them from 180, is going to give me alpha. So that gives me 38.21. And that's how you solve side, side, side. Remember, biggest side is the one you find for the biggest angle. Sorry, the biggest angle is what you want to do. And here's a word problem using this information on there. So what do we have here? We have two cell phone towers that are 100 meters apart. And so if I were to draw a triangle here, that is what we're going to get. So we have this here. And so I know that this here is 100 meters. So this one here is A, and this one here is B. And then the cell phone is right here. And so I know that it says here, so it's estimated that the phone is 60 meters from the tower A and 50 meters from B. So this is 50 meters. And this here is 60 meters. And there's the cell phone. And we want to know, authorities are looking to locate the owner of the cell phone. Will head 50 meters from B. So what we're looking for is this one here. We want to know what angle that's being made on that. Okay, very good. So again, we are given, when we're solving it, what we need to do is, if we're solving using the law of cosines, in this problem, you could do the law of cosines because that's what you're given on there. So we need to find, side, side, side we're given. So we have to do the law of um, cosines because we're using that. So therefore, it's the law of cosines. And so we need to find an angle first. So if we're going to use the law of cosines and then the law of sines, we have to find the biggest angle, right? Which is this one right here. So we would need to find this angle right there if I were doing the law of cosines and the law of sines. But I don't want to do that. So all we need to know is this angle right here. So in order for me to find what this angle is I'm just going to use the law of cosines on this one, and I don't care about what the other angles are. So I am just going to do basically just that. So in order for me to do the law of cosines on there, I am going to do, this is B, so I'm just going to say that that opposite side is B squared because that's given to us, and I am going to say that it's going to give us um, a squared plus c squared minus the 2ac cosine of beta, which is that b. And so I know that the b squared is going to be 60 squared and then 50 squared plus 100 squared minus the 250, 100 cosine of beta. And the only thing that I don't know is that angle beta there. And so we do what we did before, 60 squared minus 50 squared minus 100 squared, all divided by the negative 250, 100. And so we got rid of everything. And now we need the cosine. So we're going to do the cosine inverse is equal to beta. We put that into our calculator and we get that that's 27.1268 degrees is going to be my beta. And so this means that when we solve it here, authorities looking to locate the owner of the cell phone will lead 50 meters from the tower at what angle? So now you have to just write a sentence. Authorities will head at an angle of 27 degrees to find the owner of the cell phone. And so that's how you solve for it. Okay, very good. That is the law of cosines.